We need you to filter this image.
What?
Well, right now this is total garbage. I mean, we can't tell what's Rivers Cuomo from Weezer and what's not Rivers Cuomo from Weezer. It's useless. We need you to find all of the edges in that picture so that we can actually do something with it. Okay?
So you're saying I need to find all the edges within this image of Rivers Cuomo from Weezer?
Yes, go do it now.
Welcome to the Image Processing Helpline. Do you need to apply a filter to an image like a blur or an emboss? Do you need to sharpen the contrast between objects or maybe detect the lines between them? Do you want to understand a concept that's at the core of one of the most common types of neural networks? Look no further than kernel convolution. So as you know, digital images are represented by pixel values, which are little squares of color that make up each individual segment of an image. So if you were to convert this image into grayscale, which is how most images are processed, each pixel value would be assigned a number between 0 and 255. So 0 is a black pixel, 255 is a white pixel, and any other number is somewhere on the grayscale in between those two colors. So you can represent this image in particular as this pretty big matrix right here. And so what you can do to process this image is break it down into subsections and multiply it by a kernel matrix. So kernel is really just a term meaning a small matrix that you're going to multiply a subsection of another matrix by, and then you're going to add up all of the subsequent product matrix elements. Your kernel can have any values inside of it depending on what you're trying to do with the kernel. So this is a box blur kernel, meaning it's trying to blur the image. So we're just taking the average of little groups of pixels. So we're going to start at the top left-hand corner, and we're only going to look at this 3x3 matrix because that's the same dimensions as our kernel. And you're going to do matrix multiplication. So if you do 255 times 1/9, you're going to get 28 and a third. Then you're going to add the next element. So 0 times 1/9 is plus 0. 0 times 1/9 is plus 0. 255 is another. 28 and a third, and so on. So you're going to keep multiplying and then adding all of the individual elements. And then at the end, you're going to sum all of that up just for this one 3x3 matrix, and that's how you're going to get a new pixel value of 141 and 2/3. So that'll go into our new image matrix at exactly the same position that it is on this image. So that's 141 and 2/3, which is somewhere on the grayscale spectrum. Now that we have the first matrix done, we can shift the kernel over one slot in the x direction. So let's do 0 times 1/9 is 0, plus 0 times 1/9 is 0. You get the idea. And so now we end up with 56 and 2/3. So now we add it to the next little slot over. And so you keep going iteratively over that image until you get all the way to the bottom right corner, and you've processed the entire image. There's so much you can do just with simple matrix operations, and who knew it could be so much fun?